Okay, so this example is far more straightforward than the first one. We've got a graph of a function here. We say it's going to be translated by A units this way, A units that way, and then B units up. Okay, so we're moving right and up, where A and B are positive. The first point question says find the coordinates at the turning points, so straight to ClassPad. Okay, you can do this any number of ways, but I always like to graph it because it gives you a good sort of visual of what's going on. Okay, so if we plug that in there, right, and we can see firstly we've got a minimum, okay, that's 2, -4, and we've got a maximum which looks like it's at the origin, but we'll just check. Yep, maximum at the origin. Okay, so we've got turning points at 0, 0, and 2, -4. Pretty straightforward. Now, find the coordinates of the turning points of its image. So if we move, imagine we move this A units this direction and B units up. So we're not dilating this or changing the shape in any way, we're just translating. So if we go A units this direction, then clearly this point, or both points will move, so the 0 will become A, and the 2 will become 2 plus A. So from that point there, and now we shift it up, so the Y value of 0 will become B, and then the -4 will go up B, so -4 plus B. So therefore we've just got the new turning points will be at A, B, and 2 plus A minus 4 plus B. And that's all there is to it. So that's a really straightforward example, but again showing a good understanding of what's happening when you're translating your function. Alright, example 3. So now we've got another function with A, where we've got A is positive. Determine intervals for which f prime x is positive or negative. Now you can do this by hand, or you can do it with the ClassPad. So it's pretty straightforward by hand really, because if you differentiate it, f prime x is just going to be 1 minus 2ax, okay, and then solve when is that positive. So when is 1 minus 2ax greater than 0, when is 1 minus 2ax less than 0. Okay, and if you work that out, you get x is less than 1 on 2a, or, sorry, what's the other one? Sorry, no, that's greater than. So x should be greater than 1 on 2a, or x is less than 1 on 2a. Okay, but you can do this with your ClassPad as well, if you wish. Get rid of this. So we've got x minus, whoops, a. Now, for some reason, it does need to be a times x squared. If you just put ax squared, it doesn't like that. So we do that. Just then differentiate. Now, this is probably actually taking longer to do with the ClassPad than it would be to do it by hand, so you need to be a little bit selective. However, there you go, gives you that. So that's your derivative, and now we can say, well, when is that greater than 0? And we can solve this one. Advanced solve. Okay, and it gives you this. So x is less than 0.5. Okay, which means x is less than 1 over 2a. Okay, have I got those backwards again? I have got those backwards. Sorry, this should be the other way around. That's right the first time. So that's less than and greater than. Okay, be careful with your inequalities. It's really easy to get them mixed up. That's how you can do it with your ClassPad. However, with an example like this where the arithmetic is pretty straightforward, it's actually quicker to do it without. But just thought I'd show you that, just out of interest. Okay, part B. Find the equation of the tangent of the graph at this point. Okay, so that means we need to know what is f prime when x is 1 on a. Okay, and if you work that out, you get, so it's 1 minus 2a times 1 on a. Those cancel. That just gives you minus 1. Okay, and it does say that it's the point 1 on a going through 0. The y value is 0. So therefore, we've got y equals minus x. Okay, and you want to prove minus x plus c, 0, so minus 1 on a plus c, and therefore c must be 1 on a. Okay, so y is going to be minus x plus 1 on a. So this is for part B. Okay. Now for part C, we want the normal. So it's going to be the same, except the gradient, of course, is going to be the inverse and opposite. So if the gradient here was -1, the inverse of that is just going to be -1, but the opposite is 1. So when you multiply these two gradients together, they should give you -1. Okay, so therefore we have y equals x plus c. Okay, y is 0, with x is 1 on a, so c must be minus 1 on a. So therefore y is x minus 1 on a. Alright, so those are your two equations there. So the equation of the tangent is minus x plus 1 on a, and the equation of the normal is x minus 1 on a. Now the last one says, what is the range of f? So what are the possible y values? So talking about y values. Alright, now we know it's quadratic, so it's a parabola, so it's either going to have a maximum or a minimum. We know from the form of this, because we know that a is positive, and we've got a minus out there, we know it's going to be inverted. So we've got a maximum up here. Okay, also from what we showed here, that when x is less than 1 on a, the gradient is positive, and when x is greater than, sorry, 1 on 2a, when x is greater than 1 on 2a, the gradient is negative. So we know that this point, whatever this looks like, this point here is 1 on 2a. Okay, so we just need to find that, which means simply substituting 1 on 2a back into your original function. So we want f at 1 on 2a. Okay, if you work that out, you got 1 on 2a minus a times 1 on, and that's 4a squared, because remember this is 1 on 2a all squared. Okay, that cancels with one of those. You've got a half take a quarter a, so my 1 on 4a. So that's this value here now. That's the y value, it's 1 on 4a. So therefore, the range is going to be from minus infinity, because it extends infinitely down in the negative direction of the y-axis, up to 1 on 4a. And that's going to be a closed brackets up to and including. Okay, so that one's, again, a little bit curly, but a good one to demonstrate understanding. Okay, last question. So this one's not too bad, but it does tend to confuse students in terms of all the function notation and things, which can always be a little bit perplexing. Alright, so what we've got f of x is x cubed, okay, and we're going to translate it to f of x plus h. Alright, so what that means is f of x plus h is just x plus h cubed. So remember, everywhere that you had an x, you now replace it with whatever your transformation is, so x plus h cubed. Now, we don't actually really need to know about that, because all it says is find the value of h if f of 1 plus h is 27. Okay, so what that means is that f of 1 plus h is 1 plus h cubed, and that also equals 27, because we've been told that. Okay, so this is what we now need to solve. So 1 plus h cubed equals 27. If we take the cube root of both of those, you get 1 plus h, and of course the cube root of 27 is 3, therefore h must be 2. Okay, so really straightforward. It's just getting sometimes a little bit tied up in knots in terms of the function notation. Alright, part B. So B is very similar. We've got f of ax now. Okay, so if the point, if the graph passes through the point 127, okay, what that means is we've got f of ax is equal to ax cubed. Okay, now this is saying we're going to go through that point 127. So this is 27, the y value. when this, the x value is 1. So that's like a times 1 cubed. Alright, so what we've got is 27a cubed. Therefore, a is 3. And for the last one, we've got a cubic equation. Okay, we've got ax cubed plus take bx squared has a turning point with those coordinates, find the values for a and b. Right, so let's firstly look at, well, let's differentiate it. We get 3ax squared minus 2bx. Okay, now we know that that must be 0 when x equals 1. Okay, because we have a turning point, we have a stationary point when x equals 1. So 0 when x equals 1. Alright, so we've just got 3a take 2b. And we also know that the curve must go through this point. Alright, so what that means is we've got y is ax cubed minus bx squared. So the y value is 8 when x is 1. Minus b times 1 squared. Okay, so 8 equals a minus b. And then all you've got is two simultaneous equations. So two simultaneous equations, do that by hand or on your class pad, whatever suits. Okay, and what you should come up with is negative 16 for a and negative 24 for b. Okay, so using that bit of information, it looks like it's only one bit of information, but it's actually two. The fact that this curve goes through that point, and also that there's a turning point, therefore the gradient must be 0, therefore the derivative must be 0 when x equals 1. Okay, so you can sort of tease that out. Right, so in terms of solving these sorts of slightly more applied questions, whenever possible use your class pad to crunch the numbers, but just always be aware that sometimes it's not faster. And if you're trying to throw in things like constants, you need to be really careful that you haven't accidentally assigned that constant a value from a previous question. So it's a little bit sort of here and there depending on whether you want to use your class pad or not, but you can. And there were some examples there to show you how to do it. The true test of your understanding is whether you can interpret the results and draw conclusions. Okay, so that first example where we managed to prove that the gradient would always be positive or negative depending on the a and b values, that's the sort of thing that really demonstrates that you really know what's going on. So make sure that you're sort of really comfortable with those, and then you'll never come unstuck.